All right, welcome back to the AI Research Roundup. I am your host, Alex. Today, we're looking at a really interesting paper called TokLIP. That's TokLIP. It's all about improving how AI models handle both understanding and generating from images and text. So, previous models often struggled with high training costs and couldn't quite grasp the deeper meaning in images. This paper introduces TokLIP, a new visual tokenizer. A tokenizer is what breaks an image down into small pieces, or tokens, for the AI. TokLIP makes these tokens smarter by adding high-level semantic understanding, borrowed from CLIP, making it great for both comprehension and generation. And for those of you who want to dive deeper, the authors have released the official code for this work. In their repository, you can find the pre-trained model weights, evaluation scripts for benchmarks like ImageNet and MS Coco, and even an inference example, so you can really get hands-on with their new approach. So, this first figure really visualizes the core problem and TokLIP's solution. The top diagram shows previous approaches, like VLU. Here, the model tries to learn an image's meaning and how to reconstruct it at the same time. The paper points out that these two goals often conflict, which hurts the model's ability to truly understand the semantics. Now, the bottom diagram shows the TokLIP way. It separates these jobs. First, a simple pre-existing tokenizer, what the paper calls a vector-quantized tokenizer, handles the basic image breakdown. Then, a separate encoder is trained purely for semantic supervision, which is just for understanding the image's meaning. This disentanglement is the key to its success. Alright, so this figure dives into the details of the training pipeline. First, an image goes into a VQ-GAN encoder, which is a standard tool for turning images into discrete codes. These codes then pass through a multi-layer perceptron, or MLP. A multi-layer perceptron is essentially a set of simple processing layers that get the codes ready for the main token encoder. Now, this new encoder is trained using two clever signals, a contrastive loss to match the image's meaning to its text description, and a distillation loss to mimic a powerful CLIP model. This process creates a very semantically rich tokenizer. So after creating that semantically rich tokenizer, the next logical question is, what can you do with it? Well, this figure showcases its generation capabilities. These are examples of class-conditional image generation, which just means the model was given a category label, like bird or dog, and then asked to create a picture. The TokLIP tokenizer was plugged into a framework called LlamaGen-B to produce these images. And as you can see, the results are quite diverse and high quality, from detailed animals to scenic mountain ranges. Beyond just generating these impressive images, what TokLIP really gives us is a new way to think about multimodal models by separating the basic task of tokenization from the much harder task of semantic understanding. The researchers have created a more flexible and powerful foundation. This work really helps bridge the gap between comprehension and generation in AI. That's all for this episode of the AI Research Roundup. Thanks for tuning in, and I'll see you next time.